Hello guys and welcome to Mossy Maths with me, Tom Moss, and today we're going through the final lesson on the topic of coordinate geometry. This is lesson 6, and in this lesson we'll be reviewing the key points actually from lesson 5. There's a question I just want to go through as part of the transformation section, and this was in the AQA revision guide, and it's actually worded more like an exam style question. So I think this is going to be of more use than any of the other questions. So we've got a part A and a part B, and this is typical of what you could get in an exam. A function, f of x equals x squared, is transformed into g of x equals x plus 3 all squared minus 2. And it tells us to A, describe the transformation from f of x to g of x, and B, find the vertex and x and y intercepts of g of x. So, hopefully we can see what's going on. This function here, which is x squared, has been transformed using whatever transformation. Well, obviously it's called 1, so it's going to be a translation of some sort, and into g of x to become this. So this has become this somehow. And remembering that core 1 only requires us to know about translations, not any other transformation. So this is going to somehow relate to that. And the first part, A, which we're going to get straight on with doing now, says describe the transformation from f of x to g of x. So what has happened to make this this? Well, hopefully we can see what's going on. We've added 3 inside the brackets and squared it. So this is the part that is within the function. It's inside the brackets. And if you remember back to the previous lesson, if we have something part of the bracket, then that will either go left or right. It will move in the x direction. And hopefully you remember that it's actually going to move in the opposite way to what you would think. If it's greater than 0, and A in this case is 3, which is greater than 0, then it actually moves left. So the first thing that's happened is a translation. So we would state a translation. That's the first transformation, so we've got that right. We could say by the vector minus 3, 0, and that means that it's actually gone left 3, if we write it like this, minus 3, 0. That's the first thing. So that's one way we could write it to get full marks. We could write it in this vector form, or we could just state that it's a translation of the graph f of x moving left by 3. In other words, it's being translated left. And that will be fine, and that would also score you the marks. I just want to check that's exactly how it's worded in here, just to make sure. So in here, it says 3 units in the negative x direction. So that's the same thing. A translation, 3 units in the negative x direction. That would mean the same thing as this. So either way you want to word it, you will get full marks. Translation by the vector minus 3, 0. That's not the only thing. We have to put and a translation, and I'm going to write it in this vector notation again, by the vector naught minus 2. Remember, the bit outside the brackets is in the y direction. If it's negative, it goes down. If it's positive, it goes up. So it's going to be 0 minus 2 is the second vector. And this will score full marks. This answers part A. And like I said, you don't have to word it in this way. You can write it as 3 units in the negative x direction or 2 units in the negative y direction. And that would be the same thing as what we've written here. This is the way I'm going to do it. So part B. Find the vertex and the x and y intercepts of g of x. So, the vertex, we have done a lesson on the vertex before in one of my previous videos. And the way you find the vertex is you complete the square. Well, this actually is already in the form of a completed the square question. So we just look at the negative of what we have inside the brackets and whatever we have outside as the y value. So our vertex is just a negative of what we have inside the brackets, 3, so it becomes minus 3. And the same as what we have outside the brackets for our y value, minus 2. So this stays the same and the sign changes for this value. So this is our x coordinate, negative, minus 3, and this is our y coordinate staying the same sign in front of it, minus 2. So there's our vertex, quite simply. And we now need to find the x and y intercepts. So let's first find the y-intercept. So this will be probably 1 of 3 marks, or 1 of 4 marks. Y-intercept. So, the y-intercept is when x is 0. Of course, when it crosses the y-axis, there can't be any displacement on the x-axis. It has to be at the origin. So, our y-intercept is when x is 0. So let's just substitute x is 0 into here. We would get 0 plus 3 all squared minus 2. Well, 0 plus 3 is 3. 3 squared is 9. Minus 2 is 7. So our y-intercept is at the point 7, which is of course just the coordinate 0 on the x-axis, 7 on the y-axis. So there's our y-intercept. And finally, we need to find our x-intercepts, also known as our roots of the equation. And we do this by making y equals 0. So we make this whole equation equals 0. In doing that, we can then move this minus 2 across to get x plus 3 squared equals 2. Now we have a few options. We could expand the brackets, or we could just square root both sides and leave it as a surd, which is what I'm going to do here. So we can get x plus 3. Now if we square root both sides, this just becomes x plus 3, and this becomes the square root of 2. And now we can get this in the form x equals. We simply move the 3 across. So x is minus 3, you write the number in front, and you've got to remember the square root of 2 is going to have a negative and a positive answer. For example, if we square root 4, then we would get 2 and minus 2 as both answers, as both roots. So this is also going to have a negative and a positive value. So we say it's minus 3, moving the positive 3 across, and we say plus and minus the square root of 2. That shows there's going to be 2 answers. This will get us full marks. There, our x-intercepts. Okay, plus and minus 2. We could also write this as minus 3 plus root 2, or minus 3 minus root 2. That's the same thing, okay? Or we could just write it as 1 plus or minus root 2. Either of these will score full marks. Remember, we need to find the y-intercept, which is a point 0.7, and the x-intercept, which is this point. And again, we could write this as a coordinate, okay? We could say it's the point minus 3 plus and minus root 2, comma 0, because again, it's going to be 0 on the y-axis when there's the roots of the equation. So that will be the coordinates, but this is fine. This is the y coordinate 7, we could write it also in the coordinate form. And part A, hopefully that's quite straightforward, looking back to the previous video on translations. So thanks a lot guys, that's the 6th lesson where we've been reviewing the topic of coordinate geometry, referring back to the transformations lesson. So that's coordinate geometry complete. And now we'll be moving on to a topic of circles, where we'll be looking at equations of circles, finding the tangents, and more with circles as well. But we'll also be moving on after that to simultaneous equations. And that will be the final topic of Core 1. So we've only got circles and simultaneous equations to go. Simultaneous equations, I hope, will be quite a small topic as well. So, not far from finishing Core 1 now. So thanks a lot for watching the video. If you found it helpful, please put a like. If you have any questions, do leave a comment and I'll get back to you as soon as I can. So, thanks a lot and I'll see you in the next topic on circles.